Hello,
And we are
everyone.
live.
Yes, we are live. Hello, everyone. We have here today another session, another online talk with Mr. Adam. We would like firstly to greet and thank Mr. Adam for being with us. Thank you, Mr. Adam.
Thank you, Muad. Is right pronounced or
Yes, yes, you
yes?
can call me
Thank you,
Ali.
Muad,
No problem.
for inviting me. And he tried over and over again, but I couldn't say yes because I was swamped in project. It was not too much time actually, and I had really no time even to read emails last year. So it was crazy. But I really wanted because I like Java user groups. So I wanted to talk about that. And I asked, what is an interesting topic? And Muad said, okay, maybe AWS and this. And so, okay, but this is fresh one. Actually, I completely updated everything, rethought everything, and would like to present you a fresh idea. But interesting for me is important that you challenge me, ask questions, and you can even say, I don't believe what you are saying. This is completely wrong. My perspective is this. We can discuss. So this will be the best. So I'm not a speaker. I spend all my time in projects. So this is would be the best, right? So um, okay, Muad, any questions? So do you have
Yes,
any
so
questions or special requests from you? You are the master of ceremonies, or
yes, sure, sure. Yeah,
so no
thank you so
questions.
much. Yeah, in the beginning, maybe no questions, but maybe when we like go
Mhm.
on, of course, we will have lots of questions. I have
Yeah,
prepared lots of questions, also some questions.
very good.
Before we start, we'd like to firstly inform the audience. Please, we need like a very collaborative session. So, as Mr. Adam says, he also would like to hear your questions. If you have any questions, please drop them in the comments below. And before we start, we would like to give a brief introduction about Mr. Adam. He is a well known speaker. He is also a Java champion. He is an architect. He is a consultant. He is being like in the Java world since 1995. Uh, so we have like an early bird engineer since the born of Java. So we also would
I'm
like
not that old, what
yeah.
I was born in 2005, so it's impossible to do Java in 1995.
Yeah, yeah. Thank you so much. So we also wish a very like a pleasant and a good session. So I leave the mic now with Mr. Adam. The mic is yours. Thank you, Mr. Adam.
Thank you. And what I will attempt today is to explain you my thoughts about serverless and compare it to this what I did before still do application servers in Java EE. So what's the difference and why I think it's a good idea to at least try new project with serverless, and if they don't work, we can still roll back to um, how the default. Okay, so this is my website. It's just collection of links and funny stories. In a conference, someone assumed Airhacks is a company, and they say, "Okay, hey, how is the company?" And I say, "There's no company; it's just my website." And then I immediately registered Airhacks Industries. So this is the entire story. Um, then I do Java all the time and still really enjoy it. So this is the yeah, unusual fact about me, that I really like Java, and I get my feeling is I get more and more productive over time, and I have no desire to learn another language on JVM. What I like, other languages like maybe C from time to time or Rust, but I know on JVM I prefer Java actually. Okay, so there is a YouTube channel, and what's interesting on the YouTube channel is this. So at a conference, they asked me to record a promotional video about my talk, and it was like 2 years ago, and this is where shorts became, maybe even started at YouTube. And I said, okay, this is actually an interesting format. And at the same time, everyone said, Java is bloated and too complicated. And I said, okay, but let's record some shorts. Shorts means this is a vertical video under 1 minute. And since then, there are over 800 shorts, and I think more than a couple of million views. So it is pretty popular. So there is an average views per video, I think around 2,000 or something like that. Okay, what I also maintain is a podcast, and maybe related to this show, it was a podcast with Kelsey Hightower of Kubernetes. So we discussed now what was Kubernetes, what is supposed to be, and how it is used right now, and and what we find out that Kubernetes was never meant how it used right now, that you are editing YAMLs, and deploying virtual machines basically. And there are other podcasts serverless with serverless background. So if there are any questions left, the first Monday of the month, I'm answering all questions, and you don't even have to attend this session, because there is a GitHub gists for every AXTV episode is a corresponding GitHub gist, and you can just ask question. I answer asynchronously the question, and you can watch this show afterwards. What happened in recent years, I get more and more chat questions during the show. So this is at the beginning. Oh, what I also forgot is this one. So there are, I forgot, more than 100 episodes, 135 or something like this. And 30 episodes back, I got the idea, maybe we should look 100 episodes back. This is roughly 8 years, and revisit the questions and answers from back then, which is pretty interesting. Okay, Discord channel. I twice a year actually, I offer online workshops. Why only twice a year? Back then, I did it more often. The problem is time. I spend all my time in projects, and this is really hard to carve out time for the workshops. But they are already well attended, so they will take place. If you like, register, and and so now let's start. So I started with Java. It is actually true, in 1995, and I'm a freelancer since 1997. This is the story. And around 2000s, Java, backend Java came out, or became more and more popular. And back then, I had bad time actually with application servers, because all the application servers were completely different. It is similar to JavaScript frameworks like right now. There's like React and Angular. So what you can imagine, back then the application servers like, Tenga, which was BA, compared to Persistence PowerTier, which was implemented in C++, complete different products. Okay, but the goals or promises of J2E back then, and still now, why I'm talking about J2E, but it didn't change. I mean, it was renamed from J2E to Java-E, and then to Jakarta-E and microprofile, but I think the ideas are the same. And the main idea back then, what I remember, how it was argumented and why Java-E is so popular is because the abstraction of from the infrastructure. So in Java-E, you just you only saw your application server regardless where you operated, whether you were there was no clouds back then, but if you even were on the cloud or on premise, it was completely different. So application server, for me, the container, the idea of containers, web container and EJB container, for me, was like my cloud, right? I deployed the stuff there, and I didn't care. So, and there was a component-based architectures. Back then, we had servlets and EJBs, and right now we have Lambdas, and the AWS Lambdas, from my perspective, are very similar to EJBs. In fact, I delivered some talks and I explained Lambdas with EJBs or servlets. And for me, if you know EJBs, you also know Lambda. So there is actually almost no difference from the concepts, right? So what J2E also had were managed services, and they have a little bit different name or different meaning in the cloud. So managed service would be, for instance, S3. This is like managed services managed by AWS, right? On the application server, there were managed threads. Your components were managed by the application server, so you didn't have to or even you must not start threads, right? So relied on the application server. And Java EE was big because of the implementation independence. The idea was you could swap between application servers, and we sometimes did, and even recently we migrated an old Glassfish project to Quarkus, and it worked. So the project is maybe 20 years old, and we migrated to Quarkus, and it was easier than expected, actually. And the undifferentiated heavy lifting, which is used right now in the cloud, the idea, I think, was born in application servers. So this is what I remember. The entire argumentation about J2E is focused on business logic and not infrastructure. Forget the infrastructure and forget the threading, forget the sockets, just focus on business logic. So this was the idea back then. So any questions? So the chat is quiet. Maybe I'm in the wrong chat. So if you have a question, at least say hello. This would be cool, actually, right? So that I see that, the chat is working. So now there were some specs, and I was really excited about the specs. The first one, JSR 88, and this was deployment process standardization. So and why I was excited, because my idea was, so actually the application servers worked well for me, very well. So I used Whitefly, I used Glassfish, Payara all the time. So I started maybe Whitefly at the beginning, then Whitefly was less reusable with the version 5, I remember. Then I switched to Glassfish, and then Payara, and everyone was happy, right? And but what I missed is standardized deployment, because how application servers operated were you copied over a war in a package, or not in a package, in a folder, and the application server scanned the folder and deploy the stuff. And what I wanted to have is an API, because my idea was a Jenkins, and we have a Jenkins application server CI/CD pipeline, right? And what I wanted to have, that if I deploy my war to application server, this Jenkins stops and until it's deployed, and then I can perform my system test, and then I'm done. And the next step would be JSR 77, which was monitoring, and JSR. This is a long time ago. So the 88, 77, I remember it was like around 2003. So I delivered some talks. The 88 was the same time, and JSR 373 is newer. And this was like JSR via REST or on REST, right? So this was and everything died, actually. This was killed 2016, and 77 and 88 was killed earlier. So this is what I missed on application servers, because what I wanted to have is actually infrastructure as code with Java EE. So we coded the pipeline anyway in Jenkins, usually with Groovy. So I wanted to deploy, block, run the system tests, but it was not easily possible. So by the way, the JSR 77 was available, but this one was never released, and the 88 was somehow supported, but then was killed. Okay, so for me, the application servers were my cloud, right? My own small cloud. I didn't have to to understand the vendors. I had no interest to learn specifics about Whitefly, Payara, or Glassfish. I was just productive with Java EE. Okay, so now this is the long introduction to serverless, because you will see that for me, serverless is this on steroids. So this is like the old ideas advanced a bit and made a little bit perfect, and this is serverless. Okay, now clouds. Why clouds? So you don't have to go to the clouds. I'm actually very happy on premise. On premise, I would pick Kubernetes, Rancher, or OpenShift, run the code, and I forgot actually to create a slide, so I will have to show you this right now. So there is, for instance, Oxide Computer, and a really nice company. And this Oxide, they create some microsystems like hardware, and it looks like that. So, but it is in your data center. So I think an alternative to the, so I lost my beautiful picture. Here is it. So this is like custom-made, beautiful hardware, completely open source. So I would say this would be the opposite of the cloud, also fine, right? So you could buy a couple of them and automate everything, and you will have your own cloud at home. But in Europe, at least, so managers, I lost my slides here. Managers would like to have a cloud, and why? Usually there is like, the discussion CapEx versus OpEx, so capital costs versus operational costs. CapEx means if I have to buy the Oxide server, I have, to spend the time, the money in advance, and in the cloud, I will continually spend money. So this is like, manager talk, right? So in one point of time, management decides we have to go to the cloud. So why? No one knows, but we have to. So, and then we go, right? But if you go to the cloud, what is the expectation? And I did these experiments couple of times. With you, it is hard because I don't see anyone, and there's also no one in the chat. But in live audience, I say, okay, who never saw cloud? And sometimes there are some attendees who never worked with AWS on Azure. And then I ask the following question: how you imagine? So how you imagine cloud? So let's say you would like to have a database. What is your imagination? So how it happens? And what they say is, there's a Postgres button. I push the button and I have Postgres. So okay, this is not how it is, right? So I mean, the expectations are actually servers, right? So what the people would like to have is they only would like to know to have the service without thinking about servers. So no one will actually assume that in order to have a Postgres database, you will have to create a VPC, availability zones, and private subnets, provision the Postgres, care about the keys, and create your own backups. So the entire plumbing is just unexpected, I would say. And I think that management doesn't even know that it is like it is, right? So this is my suspicion. So I would say if you go to the cloud, from my perspective, there should be added value. And added value, it should be even more automation, even more focus on business logic. This would be the thing, right? And no ops was huge 10 years ago. But I think it's a good idea and absolutely possible to have no ops, no operations. And why? Just imagine an S3 bucket. So everyone knows a bucket, but you cannot restart the bucket. You can monitor the bucket, but the bucket just runs, right? So it will never die, hopefully. And the same is for Lambda. The Lambda starts and goes, and there is no way, to profile Lambda whether it has memo leaks. It doesn't make any sense, because Lambda runs for a few minutes and then dies. Okay, still no questions. So then Java and clouds. So I got a question all the time: is Java good enough for the clouds? So on this slide, I always show, regardless which topic on every conference, because it's quite interesting. So these two rows, the first one is energy consumption. The second row is the time. And if you take a look at the energy consumption, you see that Java is quite fast. It's a 1, 2, 3, 4, 5th place is Java here. And the same is for the performance, for time. So, and right after Ada, C++, Rust, and C. So Rust is a little bit slower than C. C is the fastest, and Java is twice as slow as C. But Python is 35 times slower than Java. TypeScript or JavaScript twice as slow as Java. Python here as well is maybe 30 times slow as Java. So and why I show you this? Because in the cloud, speed is money. The fastest, especially in serverless, you pay for gigabyte second. The faster it executes, the cheaper it gets. And the problem with Java is that Java consumes lots of memory, but on serverless, it doesn't matter, because you have to buy 2 gigs in order to have one CPU, and 2 gigs with Quarkus is far more than you can actually consume. So you could use GraalVM, but in the cloud, it is pointless on AWS. It really depends on the cost calculation. On AWS, it is not necessary. Why not? Because this is the cost calculator from, I think I made the screenshot last year, so maybe it is now even a bit cheaper. Depends on the region, of course. But what you see here, we have an ARM, and I'm assuming I will have 2 transactions per second the entire month, and the average requests are 100 milliseconds. This is the duration. So if this happens, and I'm buying 2 gigs of RAM, which is translated to 1 CPU, what I see in projects that they are booking 128 megs of RAM, which is a tenth. So this is like 1/11th of the CPU, I think. And then, of course, you would pay even less, but your application would be not 11 times slower. It would be a way more slower because Java is not well suited to run on 1/11th of a CPU. So a good spot is one CPU, which is translated to 2 gigs. And you will pay 15 euros a month for this traffic. And 2 transactions per second, day and night, all weekends, all the time, per average, is a lot for an enterprise application. And compare this costs with EC2s or with Kubernetes. So usually for enterprise, it is really cheap. If you compare it, of course, with Netflix or YouTube, then you pay premium for high traffic. So it would be cheaper or more cost-effective, maybe even, to run Quarkus on bare metal if you have really a big traffic. But for most enterprise applications, like 2 transactions per second on average, not a big deal. Okay, no questions. So now I would like to explain you serverless. Or Muad, are there any questions? Maybe I don't see them. Is this private chat or comments? This is the question. Comment. Hello. This was a wrong tab. Sorry, everyone. So from northern Spain. Hello, Marcos. So thank you. So there are I think my browser crashed.
Yeah, never mind, Adam.
This is interesting. I look at the chat and browser crashed.
Yeah, can you share also your screen, please?
Yeah,
yeah, sure.
But I would swap to the comments. Yes,
yeah.
It crashed. I swapped. I just clicked on comments and it crashed. Maybe.
Yeah, no problem.
And I read, northern Spain, and then it crashed. Maybe I never have to say Spain again. In the comments, this was maybe the problem. Yeah. So, but now I'm in the right tab. I was in the private chat. And this is why I never saw anyone. So now it looks more familiar. Nice. Pretty cool. So, Marcos, this was your fault that the stream crashed. So at least you have to ask one question, right? So this is now the deal. Asturias, yeah. That could be, but my browser likes Riyadh very, very well. So now, imagine that events. How serverless is working, I think, is pretty simple. So I'll show you this. Usually I have 2 slides. And what it is, imagine this is Apache server 20 years ago. And this is Quarkus or Payara, or no, Payara, not Quarkus. Payara or Whitefly, also 20 years ago. Glassfish. And what happened then, I don't know whether you remember, there was Apache HTTP modjk plugin, modjk. And what modjk did, it sent, modjk was, I think, for Jakarta Tomcat connector or something like this. And what it did was a binary protocol which sent, the HTTP events to Whitefly or to Payara. So that was 20 years ago. Now, 20 years later, we have exactly the same architecture with Quarkus, and we have HTTP API gateway or REST API gateway or application load balancer or VPC lattice or function URL, which I'll show you today. And what happens right now, this is a regional service. It means it is all the time. It is managed by the cloud. It should never crash, but at least I cannot restart that. It is managed by the AWS cloud. And this service is always up. And if this service receives a call from outside, what happens then, this service translates the call to a JSON event, sends the event to Lambda runtime. Lambda passes the event to Quarkus. Quarkus parses the event and invokes the old JAX-to-REST interface. So what it means is we don't even notice that we are talking, with or we are running in the cloud and receiving events from Lambda runtime. Okay, KY, I just typed hello, then it crashed. You are fault. I think the Asturians. So okay, so never type hello in the chat and never mention Asturias. Then stream will work the entire night. Okay, cool. I think I can show you some code, because otherwise you say, okay, this is not a management meeting here, right? So it talks about, stuff. Okay. I need browser. And what I have here is to think about is function URL. Exactly, Adam Bean. So what I showed you right now are Quarkus Lambda CDK plain. So this template, this is what I do usually at the beginning, but you are already sophisticated audience. So what I will show you another, I have too many repositories. What I would like to show you is AWS, not this one, I think this one. This is the repository I would like to share with you. And also not this one. There are several. This comes later. This one, I hope. Could be. So, and why? Because I have a script here, set up function CDK only AWS project. So this is, I would like to call this CDK. Okay. And it was from the, teaching perspective, bad what I did. I wanted to do something different, but forget what I did. So I created a project and forget that it exists. I will create it 10 minutes later. And what I would like to do is to start with Quarkus, CLI, create app, Airhacks, call it Riyadh user group, Riyadh Juk 2025. This is what I wanted to do, actually. Okay, now what happened is RJUK. So if I open that, it will be a regular Quarkus project. This is what I wanted to show you. And so we don't need any Docker. We don't need any tests. Just keep it simple. And we don't need any rest assured. Where is it? So just keep it simple. So this is, and we have here a greetings resource. Hello from Quarkus to Riyadh Juk. And what I also would like to do is just to add maybe a greeter Java to show you that it's actually working. Application scoped. And just go with the message, then add inject, then config property, and use name. Name is going to be message, and default value is hello from clouds. And I was told that you have end of winter and there are no clouds right now in Riyadh, but let's assume there is something like a cloud, right? So now it looks good. I only have to return the message. String message. It doesn't really matter. I just would like to have a dependency injection and config property in another class. This message. So this is like stock Java. So, and this is greeting resource and do inject greeter. And this greeter message. Okay, this could work. So let's try that. And Maven Quarkus Dev. Started, which is a good sign. What I need is I need that and localhost 8080 works, and hello also works. Okay, so Riyadh Jax asked me why Java is fast on the cloud, faster than Python and others. Yeah, absolutely. So it was number 5 on the slide, so I will come back. And Python is interpreted language in Java, and it is built in the hotspot compiler, which I would say I compared with AI, artificial intelligence. So what it does is it profiles on-the-fly methods and performs optimizations, and if it's slow, it rejects the optimization, does it again. So, and yeah, Java is crazy fast. As I saw, .NET is faster on Azure Function. Okay, Mr. N, which is it's a beautiful short name, N, said, okay, it might vary from cloud provider as well as I saw .NET is faster on Azure Function. So .NET is also compiled to native, and then it will be as fast as similar to Java, I would say. And why I prefer AWS over Azure is because this is not technical reasons. The reason is, so I'm a consultant and architect, and if client asks me, you know, what we should do, right? We have this and this, and should we pick Azure and AWS? So if you compare, the costs and the performance, they are very comparable. What's problematic with Azure is, for most of the services, they are different SKUs. This is like, so it means if you pick Azure functions, you cannot say Azure function because there are 2 versions on Azure. One is called on demand, which is comparable to AWS Lambdas, and the other one is like premium tier, and this is more comparable to Kubernetes than to Azure Function, which costs a lot of money. So, and this is always warm, the other has cold start, the other doesn't. And the problem is, if client asks me, we have to evaluate it first, what a client really needs, and then we know the price. And in AWS, there is only one AWS Lambda for now. So there is no, this is the only thing. But on Azure, you can also use serverless. So if you know what your client need, you can have very similar architecture as Azure functions. And by the way, with Quarkus, you could also run Quarkus as Azure function. Okay, thank you, N, and Ria Jack, thank you as well. Now, so what you saw is that, of course, this was the Quarkus. I started Quarkus, and of course, I could change that. And if I find the code, and where is the code? Here. So I will close that. And no. So just do it again. Okay. This was a full screen. This was a mistake. So here's the code. So, and of course, this is the old Quarkus trick, right? So if I do hello from Ria Jack, right? And if I just go here and reload it, so you see it is, yeah. Okay, now watch this. I killed here the Quarkus or the terminal. I actually wanted to kill the Quarkus, which works like that. Easy to kill, Maven package. So what happens right now is I have in target Quarkus app. What I have here, Quarkus run. So, and if I run Quarkus run jar, you see it started. So this is actually what you will ship to production, okay? So I only have to pick water. I get a question. Hi, this is Ahmed from Riyadh. Hi, Ahmed. How does auto-scaling in serverless architectures compare to ratio load balancer scaling strategies? Excellent question. Now we are talking. And of course, I knew that you will ask the question. This is why I have the slide here. So what is, I actually deleted one slide, which is a pity right now. But first, serverless Lambdas are maybe, or serverless, this is what I see, is 20-30% more expensive than EC2s, so virtual machines. The entire trick is that the serverless, they have perfect auto-scaling. So what means perfect auto-scaling? Because the API gateway is always there, they are receiving events, and on demand, the Lambdas are starting and stopping. So they are perfectly matching your load, so you never overpay. This is the entire trick. But if this were a load balancer and this were Kubernetes pods, it is almost impossible to perfect auto-scale because your pods are slower and they are different, right? There's not like a call, you would run the pods for longer. It's just more like, scaling virtual machines. So this is the difference. Ahmed, I hope, right? I hope you got my answer. So the question from Ria Jack, what about other frameworks apart from Quarkus? Another great framework which is has similar capabilities is called Micronaut. It is similar architecture to Quarkus. So why only Micronaut and Quarkus is because what they do is they optimize at build time, and at runtime there is no reflection, nothing. So this is just very quick startup time, and therefore they are very well suited for AWS. Okay. Or for AWS for serverless. Okay, cool. So my slide is here. What you saw now is the following, right? So there is a jar, Quarkus jar, and I can launch the jar, okay? So, and in production on Docker or on EC2, I would just ship the jar and I'm done. So on serverless with Quarkus, I have to do the following. So what I would like to do is to copy a dependency and say here, what I would like to have is Amazon, and I need Amazon Lambda HTTP. And what this means is that the Quarkus now should understand HTTP event from AWS Cloud. Now watch this. So I am just closing that. I have to leave my target. And now watch this. Maven clean package. And what happened? What happened is there is no more Quarkus. There is no more Quarkus app. And what you see here is function zip. So what Quarkus did, instead of deploying or creating an executable jar, Quarkus created a function zip, which is a Lambda packaging. And now watch this. Now it comes the killer Quarkus feature. What I can do right now, I can still launch Quarkus in dev mode. And what basically happens, I'm launching a Lambda now, which I can test locally, which is crazy, right? Now, okay. Now, please remember the projects which I told you to forget now, okay? So you see, my sessions are always clearly structured and practice a lot of times. So now, come back to this project was called CDK. Okay. I get another question. So what I like is the interactivity in the chat. Ahmed asked me, great, but how does autoscaling happening in service architecture if they are not using Kubernetes behind the scenes? Okay, what happens is the Lambdas are running on a micro VM. I forgot the name. It is called, it is a very nice name. I forgot the name. There's a micro VM, so it means on demand. It is no virtualization. The entire operating system with the virtual machine and the runtime is started and stopped. And even better, there's a technology called Snap Start. And what happens then is the entire stack, it means the micro VM plus the Lambda runtime and even Quarkus, they are frozen. The memory is just serialized. And the next time, there's no more startup time. It just starts, right? It's called micro VM. And because so we have internet, micro VM Lambda technology, I always think about Spark, but it's not Spark Firecracker. So I don't know. I always want to say Spark, but this is the Firecracker micro VM. So this is the technology. It is actually open source. And what's interesting is Lambda is the most secure runtime in the cloud. Why? Because nothing is shared. So the process is starting and stopping, and two processes, they never see each other. So yeah, Ahmed, thank you for the question. So you are the most eager attendee. So very good. Now, super cool. Now I'll show you something interesting maybe. What this is a Maven project which ships with CDK. CDK is Cloud Development Kit from AWS. And it is not necessary. I could actually go to the console, pick the function zip and deploy it. But in my projects, we don't do this. So what you would like to do is to automate everything and have peace of mind. So on every commit, the entire infrastructure is redeployed, and we don't care what changed. We only would like to have on every commit a full deploy. And by the way, AWS just calculates the diffs and applies only the diffs. But how this looks like, and this project is from my GitHub account, and there is a main method. It looks like that. And I created a class. I will show you this like a small builder pattern. You see this is a main method. And what this class does is it will provision, hopefully, the Lambda. So I actually plan to ship it to my AWS account. And I would like to call it Riyadh Jack app. Thank you, Ahmed. So and the function name is Sunny Riyadh, right? I forgot to Riyadh. Okay. And now I have to point to the location of the Quarkus, and I think it was a Jack. Hopefully. Let's see. Yes, Erjak. Okay, so this works, and this what I would like to have. So apologies, but usually I don't work with such resolutions, a little bit larger and one small screen, and this is why I'm a bit confused. But so looks like that. I would like to create a Riyadh Jack Java user group app. This is the function name, and should deploy this function.zip. Okay, so let's try. So I will try that. If it doesn't work, I will go briefly offline because my token expired, right? So what you will find here, this is my GitHub project, is basically Maven Clean package and CDK deploy. Okay, so let's try this. Build and deploy, don't ask. And what it does, it builds it again and tries to deploy the application. And at least the token is not expired, which is great news. And we should see the same output from the cloud, and you will see Quarkus cold start, and this will be the first deployment as serverless Lambda. And what I actually did, I used an old Java EE code to deploy as Lambda. And this is a full microprofile application. You could use Firecracker on premises or a private cloud, but it is hard to use, is what I was told. I never tried that, but you could. But by the way, the thinking of serverless is different, right? The serverless thinking is, I only would like to focus on business logic, and I don't care about infrastructure at all. Amazon or Azure should care about the infrastructure, not me. So this is the thinking. This is why, for instance, we don't even ship Java. Java is already in the cloud. We just use Java, which is deployed and maintained by AWS. This was a mistake, what I did, because I forgot the URI of the Lambda. So do it again, doesn't matter. So deploy it again, because I cleared the screen and there should be an URI. So we deployed twice without a reason, but it doesn't matter. So now it recognized the change, and this is the URI. Okay. So this is idempotent. You can do it as often as you like. So now what I would like to do is, there's a curl, and the T is just a macro. It records the time. And it was, I think, hello. So I'm invoking now the Lambda in Frankfurt, and I got the answer in 3 seconds. So I do it again, and now a 0.07, 0.08 seconds. So this is the performance of the Lambda. And Marcos asked me, the second time building was way faster, wasn't it? Yes, because what I told you, so you should listen, Marcos. What I told you is, what the cloud does, it calculates the changes, and nothing was changed, so it was faster. So this stack wasn't changed, so I deployed that, the diff to the cloud, there was nothing to do, and the cloud said, I'm done, right? So, and you see, this is the answer from the cloud. But the crazy part is, I can still test my Lambda locally and go here and to my rear jug and use Quarkus dev, and hopefully it is not started. No, and should also work. So if I go here, also works. So we have now one Quarkus on my machine, and the same code runs as AWS Lambda. Okay, and even better, because I think I was here. If I open here the Visual Studio Code, there is the AWS console, and there should be CloudWatch logs. And you see here, it created a log group. So let's take a look. And what you see is now the times. So the request took 4 milliseconds. You see here. The code startup time, build duration was 200 milliseconds. And what I showed you on the first slide is that I'm assuming the request takes 100 milliseconds. In fact, it takes 5 milliseconds, and I'm using 1.7 gigabyte of RAM, which translates to 1 CPU. And you see the Quarkus only use 160 megs of RAM. So it means I don't need that much, but I would like to have 1 CPU to run faster. Okay, super cool. So what you saw, live deployment with Maven, Quarkus, and the code is completely independent from the cloud. So this is Jakarta microprofile code. Cool. Then proceed with the slides, because we're not done yet. This was like serverless for kids, right? So there's more to talk about, and I would like to also show you something new, because I was invited last year, so I had a lot of time for preparation. From I think the first time Muad invited me, I think even September, until now, So managed services. This is easy to get or hard to get, it depends. But in the cloud, everything you do in the cloud has basically 2 APIs. The HTTP-based data API is how we call Quarkus via HTTP. This is you can see this as an data API. And the management API is with the CDK. What happened with the deployment and provisioning? And you saw this infrastructure as code. So I would say the huge advantage of the cloud is that I can automate everything, which is really hard on premise. So and my point is just, if you go to the cloud, just use it. So why not, right? So this is the idea. So this is why I thought this is the way. So I think this is how it should be, and there should be reason not to use it, right? So it's like, no, there's all these services are there, but I'm not using them. The question is why you're not using them if you already are in the cloud, right? So now J2E serverless. So if we compare now the old J2E, so I'm not writing Jakarta E, so it is like the old J2E to serverless. So this J2E was all about servers, and if you think about this, it was complete opposite, right? The servers were meant to run the entire time. They were clustered, highly available machines. The serverless is the opposite. They come and go. We have, they run for one request and then go and then come again, right? Then J2E was synchronous always and request driven. And the entire trick of serverless, it is event driven. Because if event happens, the resource wakes up and goes to sleep, and you don't have to pay for sleeping. That's all. And even, I mean, this HTTP API gateway, it is synchronous because it waits until the Lambda completes, but it's still an event, right? Then J2E was monolithic, so it means there was one server. And for me, how I envision serverless is like exploded application server. So there's SQS, SNS, Kinesis, all these services are available in the cloud, and you're in the middle and you can call whatever you like. Also, application servers were always clustered, but the serverless functions, they are never clustered, they are stateless, and they are in multiple availability zones. So, for instance, what I use in Europe is usually the EU Central 1, which is Frankfurt, and we have 3 availability zones, and every availability zones are multiple data centers, and we don't actually know where the Lambda is started. Then this is wrong. Pay as you go. First pay, not pays, but I created the slide today, so this should be reversed. So in J2E, you are paying for hardware, so I will have to fix the slide. And in serverless, you pay as you go. So you pay per request. In hardware, in J2E you pay for hardware. You usually on your company you paid the hardware in advance, and so this is actually really interesting for management. So in my current projects, what we can do, we can say, look, every order hits this Lambda, and this Lambda does this. So we can precisely calculate the costs per order. And management decides, okay, if if one Lambda invocation costs us, let's say €1, and we still earn, €2, no one cares how expensive it is. So marginal costs. And this is really hard to do with J2E, with EC2 servers, or with Kubernetes. And Lambdas and serverless, they can scale to 0, but application server is always up. So there's 2 opposites, right? So the again, these 2 last points is a mistake. And why? Because I created the header first, and then started in the reverse order, and forgot to fix the last 2 points. So this is the reason why I don't like slides. So in code, nothing can happen, but in slide, we have such a thing right now. So serverless levels. So there is no serverless levels. This is what I invented, but what I showed you right now is HTTP Lambda-lith. It means we are misusing Lambda for chip computing, and we can have as many endpoints as we like, and we just pay as you go. But the next stage would be Lambda event listener. It means I'm no more interested in HTTP events, but I write a code, let's say, which, or we could actually try. So let's create a small Lambda. Not this one. This one. Set up Lambda with CDK AWS project. So it means this is a different Lambda, no Quarkus, just plain Java. And I would like to call this events. Okay. Now there are two packages, right? So now CDK again, and the Lambda. I will show you Lambda first, maybe. Pojo Lambda. That's all. So it means there is one method on event object, and I'm just printing the object, and I created a constructor just for fun, and that's all. There's nothing else, right? So this is my Lambda, and the CDK a bit more interesting. And what happens here is I have my CDK app again. I have my stack and function name. Let's call it event-driven architectures. This is a good thing. And and what happens here is this is my builder. And by the way, to deploy a Lambda with Java, this is all you need. You only have to specify that you need Java 21. You have to specify where the jar is and your architecture, and you are done. So that's all. And in the CDK app, in the build, yeah, you see the function is created, and the function the function arn is printed. So what I would like to do is exactly what I told you. I would like to create a bucket, S3 bucket, on the fly. Builder, create this, and now call it Riyadh bucket. And I think is basically it. So the bucket name, I don't care. I would like to have auto-generated bucket name. I call it bucket, and then just create here a bucket name, and this should be a get bucket name, I guess. So this should be bucket get bucket name. Here it is. Okay, cool. Now, what I can do is bucket add something with object created notification. And what I have to pass is a target on this is new Lambda destination, and I can pass my function. So what I did right now is like message-driven bean almost. I say, hey, bucket, if someone writes something to you, please notify this Lambda. And the Lambda was just Pojo. It receives the event and prints the event. This is basically it. I think we are done. So let's let's see whether it works. So I have to find the terminal. This is the here is it. Here it is. Events. Build and deploy. Don't ask again. Build and deploy. Don't ask. The projects are on my GitHub account, and these are two Maven projects again. So it's just script which invokes two Maven projects. And now the security token included in the request is expired, unfortunately. So I have to go dark for a brief time, for a very brief amount of time, to pick my buckets. Wait a second. And you can ask questions because I see you, but I have to darken my screen. So don't worry. I'm here. I only need a fresh token, a fresh kind of a cookie. Let's see. Okay, I have refresh, reload the browser again, and pick the cookie. The token is not critical because it expires every hour, but still, in an hour, a lot can happen. Wait a sec. And now it looks better. Okay, now I'm back from black. Now it deploys the function. So sorry for that. Observability is built in. There is a CloudWatch signals. So you see, throttling events, memory, how often is invoked, errors. So this is everything built in. I could enable in buckets metrics. So and Lambda also ships with monitoring layer. And if I log in EMF format, is called embedded metrics format, then you will see alarms and metrics on the fly built in CloudWatch. What I don't do right now is I don't use the Prometheus metrics, because in the cloud you will have to pay for Prometheus, and it is cheaper just to use the built-in functionality. Ahmed, perfect. So good questions. So now my Lambda is deployed right now, you see. And it takes a bit. A bucket is created. The notifications are created in bucket. And so the bucket name is this one, events, stack, and so forth. So there should be, so what you can do is, or what I would like to do is to go to CloudWatch logs. Expire token. So do it again. Better. CloudWatch logs, and there was a nothing, because I have to start the Lambda first, I guess. So okay, the Lambda is was never started. So what I like to do is to say AWS S3 copy. I think there's a README file. Okay, copy this README file to the new bucket, and this is S3. And then I have to remember this was auto-generated name. You could have a nicer name, but it has to be unique to here. Let's see. Upload happened. Okay, cool. So let's see. And we see here the AHEX EDA. This is new, right? And what we also see is the following, that a new event happened. And you see here, event received, event versions from event name is principal ID, source IP address, and this event happened right now. And initialize with configuration hello Duke. So this is my Lambda. So what you saw right now is event driven with just plain Java 21. I registered a Lambda to S3. Now you ask me why you should do that, right? So this is a common use case. Imagine you have to upload Excel, let's say, Excel, Microsoft Excel to S3. So you upload the Excel, this Lambda wakes up, parses the Excel, translates it, and puts the results in another bucket, for instance, right? This was a general case. Or you have a data lake and you have some transformations. This is a very common case, how to react to events, Lambda events. Okay, we are almost over time, but what we have no time for today, so there's an EventBridge EDAs, and EventBridge is the next step. What EventBridge is, it is like a lightweight event router. Lightweight means it's just there, there's nothing to do. And what the EventBridge does, all the events in the cloud. So if someone commits to GitHub, or you run your code pipeline, whether the code pipeline was successful or not, whether S3 was created or not, whether Lambda is throttled or not. So all the events are aggregated in the EventBridge, and you can react to it. So you can automate the entire thing. Now, the next step is step functions. And what step functions is, it is only suitable for specific actions. But for instance, in some projects, we have the requirement that after a few days or few months, something can happen. And step functions is like a workflow. And you can say, okay, I do this, and I wait, 3 months. And if nothing happens, I'm canceling the order, for instance. And no code, this is what I try to achieve. So sometimes we only have the CDK, and we don't have any code in the cloud. What we just do is, if someone uploads the file to S3, the event is sent to somewhere else, and we just use Java for configuration, but nothing runs in the cloud. Why not? If there's nothing in the cloud from us, there is nothing to maintain. Yeah, it's completely, how to call it, no ops. Like, okay, this basically was. I hope it was something new. So I cannot remember whether I did something like this on stage with S3s, and I think you understand why this is the way, how it should be. This is an advancement over the old J2E. But for some applications, on the heavy load, several thousand transactions per second, this is maybe not the way to go, because if you would build your entire infrastructure from scratch, it will be cheaper, right? So management decision. Muad, I think we are done, unfortunately. It was fun. And after I clicked on the right tab, I saw the chat, a nice chat. So, Muad, are you already sleeping?
Yeah, kind of, because the Lambda, I'm sleeping with the Lambda.
You are sleeping with the Lambda. This was their cold start now.
Yes, exactly. Yeah, I think, let's see from the audience if they have any other questions, if you don't mind.
If there are no questions, you have to ask one. What?
Yes, of course. I had some questions in my mind. Let me see where I put them. I was wondering about, like, how can we achieve I think you came across this, the JUnit testing along with the Lambdas. I think we can consider it as any normal Java application, right?
Yes, and let's imagine the first Lambda with the HTTP monolith accesses the S3 bucket. What you can do is you can launch Quarkus locally, and Quarkus can communicate with the bucket in the cloud. So you can debug, profile everything locally, and we just communicate with DynamoDB or whatever you have in the cloud, no problem. Nice, this is pretty cool trick, actually. I got a question how I test my applications, and this is actually very easy, right?
Nice.
But I'm still in favor to test as much as possible in the cloud, because there are different CPUs and whatever, different network. So everything is automated, but for developing, it's still great experience locally. Yes, Ahmed asked me, how do we manage and optimize cost in serverless architecture, especially with unpredictable workloads? So if the workloads are unpredictable, the question is, what do you like to do, right? If they are unpredictable, it means it is not someone tries, to denial of service you, or is it like you have, Christmas or whatever you have, lots of orders, and you would like to process them all. So it will be more expensive, but what I try to do is say, okay, the Lambdas, there is a provisioned concurrency, and provisioned concurrency means you pay 15, roughly, I don't know, this really depends on the configuration, but it's like, let's say 20 euros a month, and then the Lambda never gets cold, right? So it is always warm. And the opposite is not provisioned, reserved concurrency. So you can say, I only start 10 of the Lambdas and never more, which protects you from unwanted load. Maybe everything else gets throttled. And what I do, Ahmed, is, no kidding, the first week in my projects, I sit down with the managers with cost calculator, and we do the math. Is it worth or not? And the first time of history of Java, maybe, we can actually do this. Because on Kubernetes, you pay for the entire Kubernetes cluster, and no one knows what's running on the Kubernetes, right? So you pay thousands of euros, and they say, okay, what is running? So I got the question constantly, we are paying a lot for the infrastructure. For what are we actually paying? What runs inside the machine? On a Lambda, you see exactly this use cases cost you exactly that much, and the others are cheaper or more expensive or whatever.
Yeah, sounds good. Do you recommend that if we have unpredictable workloads, do you recommend that not to use Lambdas? Just use.
You can use even both with Quarkus. The cool story is you can have application load balancer, and application load balancer can target Lambda. So you can have application load balancer, Fargate, and Lambda, and you have the exactly identical Quarkus application. and the load balancer, uses just your container of a peak load lambdas, for instance, or other way around. So both.
Yeah. I got it. Yeah. That's very, very nice. I mean, very nice option. Also, have you come across this one? Is like this one is maybe production. Have you come across?
But maybe to you all, my motivation is not to build highly scalable system. Maybe I forgot to introduce myself, actually. I spend time in mostly boring enterprise projects, like database, CRUD, business department does something, and they are paying thousands of euros for Kubernetes cluster, and it is the CPU usage maybe 10%. For such applications, serverless just shines because you pay nothing, virtually nothing. Some project doesn't cost us anything, and if there is a load, let's say all people are from vacations, all 100 people are back from vacations, and we get 3 transactions per second, then we get them, and then the system sleeps at night again, right? Another interesting story. There's a big conference in Frankfurt called JAX conference, and 2 years ago I delivered a talk about serverless, like introduction, and I think the title was like, are you EGB developer? Then you understand Lambda, something like this. But someone listened in Frankfurt and they applied the ideas to their project. And the year later, they say, we did it. And I asked them, okay, how much load? And they say, entire company uses our Quarkus on Lambda. And I asked them, how much are you paying per month? And he looked up and say, like 60 euros per month. This is nothing. And back then it was thousands of euros. So you have to be careful, with Netflix, YouTube, it will be too expensive. Or you cannot run Riyadh Java user group with millions of participants on that, right? But just kidding. But for boring enterprise applications, I think this is the way to start. You don't have to maintain it. You don't have, it cannot break. And usually there is no peak load, because if you only have 200 or 300 employees, this is all you can get, right?
Yes, I got you. Yeah, awesome. I have also couple of questions, if you don't mind.
Very good.
Yeah, regarding if I have multi-cloud environments, for example, imagine that we're having like a financial application where this has to have a backup or a DR in another cloud. So we have AWS as the main cloud, or for example, the DR disaster recovery is in the GCP cloud. Okay. Now, if we want to ship our Quarkus or Micronodes or so whatever, now how can we ship? Firstly, in build, we need to put the two dependencies. One is for AWS and one is for GCP as dependencies. Then how can we like build both, then ship in two? Or I'm not sure how can we achieve this?
Yeah, Azure Functions and AWS, I can tell you, GCP, I never tried that with Quarkus. But in Azure Functions, what would be different? So on Azure Function, if you go Azure Function Quarkus Maven, the main difference, it is a Maven project from Microsoft, and it looks actually identical. And there's a Maven plugin. On this Maven plugin that does basically the same. So it means your code would be identical. And what I will do is 2 Maven profiles, one with the AWS Lambda and the other one with Azure Function. And this should work. So you can have both. Or, maybe even 2 POMs. And then you can run Maven with -s, I think, and you point to different POMs, and then you can switch between them. This would be another option. And but another question, because you say financial institutions, so sometimes they say, what about the dependency on AWS, right? Because let's say I'm now using the events, I'm completely dependent on AWS. But I think you have 2 options, right? One option is just write minimal code and be dependent on the cloud. And if you have to migrate, you migrate your minimal code to the other cloud. Or the other option is build framework around the cloud and then hope that you abstracted whatever you had, and this will run on another cloud, which I don't believe, because this is way too complicated. And my observation is the migration was never Java code or something. If someone had to migrate from AWS to Azure, I think the main challenge is the right permissions. Don't use star permissions or really nice fine-grained permissions. Networking, IP addresses, routing. This is where you will bite you. Not necessarily migrating the Java program. And this is what managers don't get. They think if they use Terraform and Java and they build their own framework around the cloud, then they are portable. But I would say they are not, because it is harder than you think, even if your framework, this framework is not a problem.
Yeah, I see. Thank you so much. My last question.
So right now, my advice or my thinking is write lean code to the point, focus on business, not the infrastructure. And if you have to migrate between the cloud, then just do it, right? So then you have to migrate your minimal code between the clouds. And by the way, S3 is almost standard. You can use S3 on Cloudflare. You can use on AWS. There's even on Synology stations, you can use S3. It's almost like a standard, became a standard. So
yes.
Yeah,
I see. Yeah, it's the same way for the buckets, exactly. For the Azure, just differs from this. Yeah.
Blob storage, but it's also similar. I mean, the Azure blob storage and S3 is very, very similar.
Yeah. So, do you see like Spring Boot, especially with the latest improvements that been added, especially Spring 3, would be a good competitor for Micronaut and Quarkus, or you don't recommend it for serverless?
It's the same like application servers, right? The application servers also evolved. But the fact is that Micronaut and Quarkus, they were built from scratch to optimize everything at build time. And at runtime, there is no reflection, no dynamic behaviors. They are crazy fast. And Spring Boot was the opposite. They were highly dynamic, and now they try to be afterwards static. And what I showed you right now was not GraalVM. I didn't even use GraalVM. I'm using the Java 21. And what Spring optimized, I'm not an experienced Spring developer, but what I heard, what Spring optimized is GraalVM. So you can have a native Spring, but if you think about this, GraalVM deployment is the opposite of serverless, because you have to build the image somewhere. You have to decide which GraalVM version you pick. You are depending now on GraalVM and Spring, and you have to build it in a pipeline and ship it to as a function, right? So now, if there is a security patch necessary in GraalVM or Spring or somewhere, you are in charge of redeploying all your functions.
Yes.
But in Quarkus, I use Java 21, which was already installed in the cloud. And you remember the log4j fiasco, the problem with with the log4shell.
Yes.
So what they did in AWS, they just disabled this part of Java 21, so it was fixed for you. So I would like to have the full adventures. I don't like to care about the infrastructure at all. So I would say with Spring Boot, you can achieve similar things. But what I heard is that Spring Boot startup time is way slower than Quarkus. And this is the problem, right? And also, funny fact, at these workshops, if you attend, maybe you will meet, he will attend actually in December, so you can ask the guy. He wrote about a book about Spring Boot, and now he uses Quarkus in the cloud. He says, no way. So this is what I can, I know, his first name is Alex, so if you search for it, maybe you can ping him. But he runs, serverless workloads on AWS with POJOs, and I made Micronaut or Quarkus. I forgot what, but one of them. POJOs, Lambdas for sure, and then Micronaut or Quarkus. So I will ask him in the summer. But yeah. Very good questions, Muad. So we're also working on in the cloud a lot, right?
Yes. We
Cool.
have huge financial. Actually, we work in the bank. Our bank is whole in the cloud. Yes.
Okay. So hopefully
So
it was something new for you, not boring.
Yeah. It's absolutely amazing. So still, to be honest with you, we are not using anything related to serverless, but of course, we have to do some experimentations on this. Yes.
So no one wants to have serverless because it's widely misunderstood. But if I have the opportunity, and they ask me what you should do, and I have the manager in front of me, and the manager is responsible for the money, and I show them calculations, I always get serverless. So, and it was never the case they say, okay, go, we pick, EC2 or Kubernetes, never. So all my projects from starting with the pandemic are serverless just because of the costs. And what I forgot to mention, the entire point of cloud is cost-driven architecture. All the decisions around money. Otherwise, it doesn't make any sense. Otherwise, I would just book, the largest EC2 machine, deploy Quarkus, and I'm happy, right? I'm not crazy. So the entire circus here is just because to save money. It's not,
Yeah, absolutely. Of course, we will.
Also, the last funny story in Europe. So I was hired in Germany for a project, and I showed them serverless, and they say, "What are you talking about? We are not paying anything." So I go, "Who pays your bills?" So I go, the company in Switzerland. We don't care how expensive it is, and it died immediately. So they were not interested in serverless. So I go, we deploy whatever. We don't care how much it costs. So in such a discussion, it doesn't make any sense to deploy serverless. If they have endless budget, who cares? Because it is more painful to think about cold startups or whatever. But you can save a lot of money if you know what they're doing, right? So this is the point. Mm-hmm.
Yes, absolutely.
Ahmed asked me, do you recommend all these startups should go for serverless architecture? Ahmed, I think so, because not only for the costs, because startups usually have some funding, but because there's no operations. So most of my services in my cloud, in my private, small things which I build, automations, always serverless because it always runs. And if you have a Docker container or Fargate, the pods get sometimes restarted. I don't trust the thing, but serverless, it comes and goes. It always has a fresh start, So there is no reason not to use it, I would say.
Yeah, I think one question came to my mind. Of course, we can run the serverless through our pipelines, right? Of course, we can automate it and run it through the pipelines, right?
CI/CD.
Yes, exactly.
Yeah. What? And all the pipelines are serverless. And even more interesting, all the pipelines are provisioned with CDK. So what happens is we have, it's called code pipeline, is the pipeline, and it comprises CodeBuilds. These are the stages. And what happens in all projects right now, we have private GitHub repository. If we commit stuff to GitHub, the code pipeline wakes up and the code builds are starting. But the cool story is the code build is exactly the same code like here. There is just CDK deploy, and my system test. So there is no specific code. It's just the same code I showed you in terminal in the pipeline. We can do this next time. So in 1 year or 2 years. So we can go to part 2 where I showed you what the pipeline is actually doing. And the pipelines in my projects are run all the time, and we pay maybe 40 euros a month.
Oh, that's really amazing.
This is really nice. They are serverless. They are also go sleeping, and they wake up, go sleep, completely serverless. No one cares about it.
So you mean the pipelines also based on serverless?
Yes.
Oh,
code
that's
pipeline
awesome.
And code build are based on Fargate, I guess. It looks for me like container, and they are never active. They're only active on commit, and they go to sleep. And you can buy a crazy amount of CPUs, but usually 2 CPUs are enough. And we are committing like crazy, and we in current projects we never were more expensive, like 40 or 50 euros a month.
That's insane. That's awesome, really.
If you like, next time we do the pipelines.
Yes,
no problem.
Sure.
Few Java pipelines, of course.
Yes, sure.
So now Amir asked me, we have another attendee, so we have to ask, what about project related to IoT and need much connections to the server and processing much data? Also covered, I don't know whether I would call it serverless, but there is a Greengrass project on AWS. James Gosling actually work on that. And but regardless of things, there's a Kinesis, which is very similar to Kafka, and the consumer of Kinesis is Lambda, right? And long story short, what we had on the slide is, the first slide was the following. So this is the basic calculation, and this is proportional. So it means if we have 2 transactions per second, and it takes 100 milliseconds, then it costs $15 a month. So if this would be 1 second, it would be 150 euros a month. But if you have event processing, such a Lambda, you saw already, it was like more like 5 milliseconds. It means we could have 40 transactions per second with 5 milliseconds requests, which is doable with Java. It will still pay 15 euros. So of course, if you have millions of events, you will have to pay for it, right? But the question is, if you have millions of events, would EC2 be cheaper then? This is the comparison, How many EC2 instances do you have to start? Who will maintain them? You have to maintain them. How you will patch it in running system? This is not as easy as it seems. And there is no patch, no ops, nothing. But Amer, great question. And
yes.
As I said, I recommend serverless for everything, because you don't have to focus on infrastructure first. And if you find out, and you will find out in the cost calculator in 2 days whether it's going to be expensive or not, and you can still afterwards take your code and run it in EC2 or Kubernetes. Not a problem. It's not like it's one way, right? You can say, okay, I started with serverless, and there is no operations, and if it's too expensive, I migrate back, no problem. And the cost, absolutely. Amer, you said the cost will increase. Amer says this cost will increase if you have more devices. Yes, but this is proportional. The amount of devices is directly proportional to the cost. Is linear. 100 devices, you pay $1. For 1,000 devices, let's say $10. This is like it is. And if the device, you have to charge your client, and then you are golden, because you have to charge per device your client, and with every device you earn more money. This is the thinking in serverless, right? And in Kubernetes, it's like, you have maybe 2 machines, and it goes well until it breaks, and then you need 4 machines, and then the costs explode, and then it gets cheaper and cheaper until it explodes again. This is completely different idea. I hope this is like I'm just saying what is simpler and how it should be. And for years we had the conversation, Java focus on business, and now we can really focus on business and forget the infrastructure completely. And this is why I like the idea, because it's consequential. We say, okay, we go this, and if this doesn't work, then do the fallback, right? So this is the idea.
Yes.
Thank you a lot.
Thank you.
Nice community you have in Riyadh.
Yes, we have really good active communities. We have nice, and also we would like to extend our thanking and pleasure to you, Adam. Really appreciate your time. I really appreciate your useful content. Amazing session. I really liked it a lot.
Thank you.
And we ask the community to follow you on Twitter if you need more information. If you also Airhacks, his YouTube channel, you can follow.
Yeah, Airhacks TV. You can ask questions, once a month, or LinkedIn or whatever. So just ask questions, Twitter, whatever, and I will try to answer. And I record the shorts on Airhacks TV. We have 1 hour like this. It's freestyle, so I answer all such questions. So if you have some questions left, ask on GitHub Gist and search for Airhacks TV. There's a live stream. It's first Monday of the month at 8 p.m. It's the same time.
Thank you so much, Adam. If you have any final words before we end the session.
Thank you, Muad, for your time, and all of you. What I overlooked is this later than in my case, right? So usually I schedule everything late because, with US, this is convenient for them. And what I noticed, right, is I wanted to apologize. It is late for me, but later for you. So the next time maybe we do at 6 or 7, this would also work. So next time we do more convenient Riyadh time.
No problem. Actually, nowadays we are celebrating Ramadan. So Ramadan is the holy month, fasting. So we actually we have like some activities in the evening. So we are enjoying it.
So Ramadan, you are allowed to eat or not to eat?
We are not allowed to eat in the daytime.
There is foodless, not serverless, the daytime, right?
Yeah. yes. yes. So we have only events at the evening only.
Okay, cool. In the evening, now everyone waits, stop talking. We would like,
exactly.
to go to our dishes, right? So it's like when he stops talking about the Java stuff, right?
No, we already broke our fasting. We already broke
exactly.
fasting like 4 hours ago. All right. Thank you so much, Adam. We'd like to also big thanks to the audience, and looking forward to hosting you again and again. And here we say goodbye for everyone. Good night. See you later.
Bye. Good night.